go. Today I want to have some coffee with you guys and talk about RAM. It's very nice. So RAM means a lot to a lot of different people, and I can show you sticks like this all day long. There's little chips and it goes in the computer, but that doesn't really mean much. When you're the user and you're using a computer as a tool, RAM means something else. And we're gonna get into 7 different types of people, and I can almost guarantee you're one of them. If you're not any of those, you're a technician like me who is trying to get an understanding to be able to explain it to other people. So, hope this video will be helpful, and if you guys haven't subscribed already, subscribe, creating awesome content here, and let's get on into it. So I know a guy, I was working with him one day and he asked me, what is RAM? And this guy loves to play games. He's a big fan of RimWorld, Civilization, plays some Call of Duty, all of this on his PC. And I said, RAM is where your games are stored when you're playing them. So when you fire up City Skylines and all of your little people are running around and all of the cars around and there's tons of buildings, all of that is stored in RAM while you're running the game. And for a gamer in this situation, some of it's stored on the graphics card, so like you have it's kind of a silly concept to explain, but there might be the city as a series of values. So like a road is on this XY coordinate, and then there's a building at this XY coordinate. There is a specially named building at this Y coordinate on this intersection or whatever. The stuff that describes the city, that is stored in RAM. And then when you actually draw the city, when you actually have the blue building that is 60 feet tall and it has windows that look like, things, braces, all of that is being drawn, and it's a drawing, it's a living drawing that is stored in your graphics card RAM. And he asked me, like, hey, what's more important? Should I have the system RAM or the graphics RAM? And I said both of them are important. You can't really have too much or too little in one area. For the normal games like Fortnite, City Skylines, Civilization, those games are pretty well balanced on storing stuff in RAM and then storing stuff in the GPU memory. GPU RAM. By the way, these RAM memories act differently. Over here, it's important to store a lot, and then over here, it's important to have a lot of bandwidth, and it has to be accessed a different way. So just don't directly compare them as far as performance and stuff. I don't think you'll get any useful statistics from that. So I told him, hey, they're both important, and when you run your games and they're kind of slow, and that could be a RAM issue. Maybe you don't have enough RAM and the system is swapping stuff out of the hard drive really a lot, and your game's running slow because of that. It could be one thing. Maybe you just have a slow processor or a slow graphics card. When you're diagnosing how to make your system faster, or the inverse of that is, why is my system running slow? RAM is one of those core components to take a look at as far as a gamer is concerned. The next person I want to explain RAM to is the office worker. I know, and I have met a lot of people in my life who the computer is just the necessary evil sitting on their desk, whose only purpose is to hold a spreadsheet and sometimes print successfully the spreadsheet so that you can actually look at the spreadsheet. What is RAM to you? RAM is everything you're looking at on the screen. So if you are looking at the spreadsheet is stored in these series of chips. To access them really fast, they're on these series of chips. Whenever you start up Office, Microsoft Office 365, I know that that's just a bulk of a program. And it might take up to a minute, 2 minutes, 3 minutes, depending on how your system is. That is the act of taking stuff from your hard drive, your storage, your long-term memory, and putting it into the short-term memory of your computer. And Office is such a big program that it actually takes a bit of time to move everything in there. And RAM is where Office is being put to in that process. RAM is also the reason that when you turn off your computer, or when the power goes out, that's actually a better example, you lose all of your files, everything that you're working on. Well, this, while it says it's 1 gigabyte of capacity, all of that is completely clear. Everything is a 0 on it right now. It's only when I turn on the system and we fetch stuff from our hard drive and load it into RAM is data on this. And when the power is turned off, all of this is cleared. And if Microsoft Office is stored in RAM and your spreadsheet is stored in RAM and you haven't saved it yet, and it was the beginning of the day and you just made the spreadsheet of yesterday's sales figures and the power goes out, well, your file was in one of these chips, the power went out, and it's nowhere. It's gone. So maybe that can explain some tragedies that you might have experienced. To some people, computers are just tools, necessary evil of the office. And this is how RAM kind of plays into this. So a third type of person to explain RAM to is the database administrator. And you don't really see these people a lot, but if you keep records at your company, say you work at a Walmart. Walmart has a huge database. It's actually a real-time living database full of inventory, sales figures, profits, and etc. All of that is actually stored on a physical server. That server has particular RAM necessities, so it needs a lot of RAM. If we need to store a giant living program, storing it in 1 gigabyte might not be enough. Storing it, this program might blow up to be like 30 gigabytes while we're actually in runtime and it's up and it's available to the users. And it's important to develop a system that has the capacity for all of that program running at once. So when you run into Intel Xeon processors, they have huge amounts of RAM support, and they have lots of channels of RAM to swap stuff in and out really quick. This is something to take a look at, and if you are designing a system to have a really complex, a really important thing, capacity is something to take into consideration. Another thing is called ECC, error correcting code, and I'm not going to go into great detail, but if your time is money, and let's say your database shuts down and you lose $10,000 for every hour, that's a huge problem. And that's losing money. You know, people are on the clock, but they can't check out anything. It would be important to look for error correcting code memory, and then the supporting platforms to support that, just to take another possibility of your system crashing out of the loop. So you give it a battery backup, you give it error correcting code RAM, you give it multiple different internet connections. It's building this redundancy and reliability into your system is very important. And there are particular RAM applications that can fulfill this special requirement. There we go. It's completed my masterpiece. There we go. Look at that. I did that. No, not really. My wife did. So the purpose of this was to say, fourth type of person I want to talk about is artist. So this is an iPad. A lot of people use it for its famous app called Procreate. And if you are any kind of creative professional, you've probably heard of Adobe products. Whenever you are creating or working in a project or an artwork, what you are doing on the hardware level is taking stuff from RAM, throwing it in the processor, changing it around, putting it back into RAM, and then just this constant back and forth until you have the right type of data to create beautiful artworks, great sounds, awesome video files like this one, and maybe great web applications and subscribe buttons, and how the subscribe button changes when you click it. So just stuff like that is, when you're a creative professional, all of that is in RAM, and RAM is as I said before, it's a stick, but when you're an artist, what RAM is that comfortable workspace. It's this big, giant digital table that you can throw whatever you want on it, and you can work with it, and you can change it. When I edited this video, I put it into Premiere, and guess what? It took 4 gigabytes of RAM, and that was my digital work table. And when I changed around the video, I took the video from the RAM, processed it, put it back into RAM, saved my project, and then exported my project to YouTube, which is, off my computer. But when I was actually working with it, it was in RAM. And having more RAM is nice when you're an artist because, your digital work table is really big. But after a certain point, it's like, okay. The difference between 8 gigabytes and 64 gigabytes will never be realized if you are using a simple program such as Photoshop, or maybe you're designing a web page. But for more complex tasks, such as video editing, having 64 gigabytes of RAM might be really cool. Maybe you can up your quality to 4K definition, or maybe you can add more 3D effects to work with and be able to do all this in real time. RAM is really fast. So if you're an artist out there and you work with digital files, change video, make music, you're using RAM, you're using it in your production, and it's really cool. It's really cool how it works so fast and we can do so much. It's cold. The code is finally complete. I can now run this thing. It's great. Nah, just kidding. I wrote some gibberish in Notepad. But there are some people who love writing code and running that code. And eventually code from Java or C turns into what's called a program. And we run the programs on our devices such as our laptop, our tablets, our phones. Someone even wrote some software that is processing this recording of this video within our Canon EOS Rebel T7i. So someone wrote a software to use the sensors on the camera and to process it and store it in the SD card. And all of that's happening right now. It's actually pretty cool. So what is RAM if you are one of these people who loves to write code? RAM is where you test your code. It is where your project comes alive, and if it crashes, it's probably where it'll die as well. So when I write code, it is in Notepad and is compiled to code and it's actually executed. It is loaded into RAM, and then the processor takes that first command of start class, and it runs everything. So whenever I run a program, I had said this throughout the video, such as Photoshop or Word or Premiere or Procreate, all of these are software that has been written by programmers. And these programmers, I think, all of what I've mentioned has been really great software. I think they've had an understanding of what hardware is, specifically what RAM is, and what constraints they were working with. Take, for example, this iPad. I think it only has maybe a gig or 2 of RAM. And it's very limited, and the apps you develop for this are going to be way different than the apps you develop for, the creative professional laptop. This has 16 gigabytes of RAM, so I can run a much more complex program such as Premiere on this, where I cannot run Premiere in its full form on my iPad. It just wouldn't work. There's not enough physical chips, there's not a big enough workspace. So if you are developing software, it's really important that you understand RAM and you understand the limitations of your devices. It's always limitations. So if you take, for example, there's actually a program called Microsoft Office Word. Really great program, been around for like 40 years. Word, you can now run it on your phone, you can run it on your tablet, you can run it on your laptop, and you can also run it on a online application. Now what I've just mentioned are 4 different devices running Word. My phone might have a gig of RAM, my tablet might have 2 gigs of RAM, my laptop might have 8 gigs of RAM, and then the server that Office is running on, it might have 128 gigabytes of RAM, but also might have to support, 500 users at once. So there's technical challenges that are presented at every different port or every different thing that comes about. So if you're a software engineer, you have to be aware of these. You have to be aware of the environment you're developing for. And it is the same as if you are writing a book and you have to understand your audience. If I'm writing a Civil War book for high schoolers in the Midwest, well, that I know what I'm writing towards. I'm not going to write it in Chinese. I'm not going to write it in the perspective that we live in Brazil, and I'm not going to write it in the perspective of how this compares to other wars. I want to just explain this war. So that might be an example of a challenge that is presented by a writer. Software engineers have these problems as well, and knowing about RAM and the devices you're working with really helps create ultimately a better product for the end user, which is what it's all about. Gotta have some more coffee. That's great. So the 6th person I want to get to explaining RAM to is an electrician, or maybe an electronics person. Not everyone loves software and operating systems and code. There are some people who just want to work with the physical internal stuff, put transistors, resistors, voltage sources all together and make something beautiful and magical. Well, let me explain RAM to you in a way that you would understand. So RAM is standardized by JEDEC, the Joint Electronic Development Engine. I don't really remember what it's called. There's a group of people who decide how this is going to be made. They decide how long it is, how many pins are here, how many chips are allowed here, and what types of chips are allowed there. They decide how everything goes together, so you're not going to see a whole lot of variation between RAM chips. A RAM stick is a series of chips. There's a small ROM, read-only memory, that has some basic data about the device, has some semiconductors, and on these chips, what random access memory is millions and millions of capacitors, all laid out in rows, and they have to be dynamically refreshed every few nanoseconds. It is, they have a temperature variance within, a lot of other transistors. They're built on a 20 nanometer lithography process, and they just are really cool. Also, they're pretty tough. I've thrown that one around a bunch. It probably still works. I don't know why, and I'm never gonna test it anyways. So that is kind of a basic rundown of what RAM is to an electrician. And we could go on and on about how complex they are and how it takes many different levels of engineering and manufacturing and research to create them and to create new technologies. And there is people who gather together, such as JEDEC, who decide that and decide the specifications. RAM has gone through many revisions, such as DDR1, 2, 3, 4, and this year hopefully we'll see DDR5. So all of that said, that's what RAM is to an electrician, and I'm sure there's more to be contrived from that. So here we go, we're at the 7th person, and that is just a normal old person. The person who just wants it to work. You're going about your day, you swipe your card on the point of sales, and you hope the RAM in there just works to process your transaction, to go home and eat hot dogs or whatever you eat. There are people who pull up their smartphone and they get on TikTok and it just works. And the device just works. And there's no problem, there's no issues being between the user and their experience of using the device. And if you are a technician like me, you are trying to develop the best technical experience for someone to have. And it's really important to understand that the needs of the gamer and the office worker and the database admin and the creative artist and the software engineer and the electrician, they're all very different. And ultimately, these are the normal people in their field. And when you create a device, or you push a device, or you advise on a device, or you modify a device, you have to understand that your actions should not create a barrier. They shouldn't create a problem. It shouldn't crash all the time. It shouldn't be slow. It shouldn't be so pricey that they can't afford it, or it's not a great value for them anymore. So the seventh person is just the normal person, and it works for them. And I fill this role in a lot of stuff in my life. So like I said, I go to the store and I buy something. I pull up my smartphone and I call someone. I get on my laptop and I play video games, and it works. And I edit videos and it works. And I do all this stuff with technology, and so many devices have RAM. Like all of them, nearly all of them that do something useful have RAM, and it just works. It just works. I don't know what else to say. There's nothing really else to say. There shouldn't be anything else to say on this. It just works. I'm gonna have my coffee now. Y'all have a good time. I hope this video has gave you a great introduction to RAM. Thank you all for watching. Drop a like, subscribe, it really helps the channel. I like what I do. I love explaining electronics and technology and computers and whatever field I'm in a lot of different fields. So I'd appreciate if you guys supported the channel, and drop a comment down below. What type of person are you? On the general. Are you the creative professional? Are you the gamer? Are you the database admin? I'm really curious to see where you see yourself, and maybe that could better help you understand your needs for RAM in the computer systems that you use. All right, that's all. Thank you. Bye.